Yes, yes. So your mic is not working. Sneha, can you speak again?
Yes, sir.
Okay. Thank you. I was just checking for my Bluetooth. Was it connected or not? So in the previous class, you have seen that we were doing the nomenclature part only. So does anyone have any doubt in nomenclature? Please let me know. Is there any doubt in nomenclature? And I had given questions. I think I had given question. So this was the question in the previous class, 1, 2, 3. Have you done it, Sneha, Nafisa? Okay, Sneha, if you are done with this, is there any doubt that you want to ask me? So please send your, as I already told you in the previous class, that please send the PDF or the pic of this solution of this question. No one sent me. In the second D1. Wait a minute. Are you talking about this 2,3 diethyl phenol, Sneha? Second question, fourth part. It is basically 2,3 diethyl phenol. So basically, we just need to write the structure. This is phenol. First of all, this is phenol. This is our phenol. And you know that this is the functional group, so we will give preference to this. So this will be 1, and then this will be 2, and this will be 3. So you are going to add CH3, CH2, CH2, CH3, ethyl group here. So this is the structure of this compound. Is that clear, Hamza? Why were you absent in the last class?
Sir, I was attending a function.
Okay, you were attending a function. Okay, no problem. So Alia, why you also didn't send the solution of this question 1, 2, 3? Okay, let's start. No one is responding. So let's start the next topic, which is preparation of alcohols. Preparation of alcohols. So see how we are going to prepare alcohols. So the first topic comes here, from where we are going to prepare. It is basically from alkenes. From alkenes. So how we are going to prepare alcohol from alkenes? It's very easy. There will be basically there are two ways of preparing alcohol from alkenes. So in this we are going to learn the first one, and it is by acid catalyzed acid catalyzed hydration. By acid catalyzed hydration, that means if you are going to pass an alkene through water in the presence of acid will act as catalyst, then you will get alcohol. It's very easy. And everyone knows about Markovnikov and anti-Markovnikov in the previous chapter. Yes or no? Please do respond. Sneha, Hamza,
Yes, sir.
Alia, and Nafisa. Okay.
Yes, sir.
Nafisa, you also didn't send the solution of the three questions, one, two, three. Why it is so?
So after tuition,
Is
I
there
had
any?
to study for exam.
Okay, so I think you can give me today or by tomorrow you can send the right.
So I can send today. It's okay.
Okay. So first of all, I'm going to write a statement about this reaction. Alkenes, write with me. Alkenes react with water in the presence of acid, and this acid will act as catalyst. So in the presence of acid as catalyst to form alcohols, to form alcohols. And here Markovnikov follows. In case of asymmetrical alkenes, asymmetrical, asymmetrical alkenes, the addition reaction, this is addition reaction takes place in accordance with or according to, I'm writing accordance with Markovnikov's. So first you are going to write it and then I'm going to explain it, how it gonna, how the reaction will take place, and then we will talk about the mechanism of reaction, which is very easy. Please let me know when you are done with this.
Yes, sir. Finished.
Very good. Everyone done with this? Okay. Alia, Hamza. So see what happens here. If you have an alkene, can you tell me whether it is symmetrical alkene or asymmetrical alkene? Can anyone tell me whether it is symmetrical or asymmetrical? What is the name of this alkene? This is an alkene, yes or no?
Yes, sir.
So it is an alkene. So can you tell me it is symmetrical or not? So in order to find whether it is symmetry or not, just break this bond. And you can see left hand side will be as same as right hand side. That means it is symmetrical. Yes or no? So in symmetrical, the reaction how it gonna take place. As you know that H2O will have two parts, H plus and OH minus. And in order to add something new, we have to break the old bond, one of the old bond. So I'm going to break this bond. So either you can add hydrogen here. Oh, wait a minute. Either you can add hydrogen on the left carbon and OH on the right carbon, or either you can do the reverse of this. It won't affect. Both are same basically. Both are same. These are identical because it is symmetrical alkene, because this is symmetrical alkene. Is that clear?
Yes, sir.
Now if you have, focus here, if you have asymmetrical alkene, like if you have propene like CH3 CH double bond CH2, and you are going to react this, hydration takes place, that means water in the presence of acid, which will act as catalyst. So this will have two part, H plus and OH minus, and one of the bond will break in order to add new bonds or new compounds to this. So you can see CH3, CH and hydrogen can be added here, and you will get CH2OH here, or either you can add like CH3 and then CH and then here it's OH and then CH2H. So here you will get two products in asymmetrical alkene. Asymmetrical alkene, you will get two products, but you have to decide which one is major and which one is minor. So you can see this will be our major product, and this one will be our minor product. So if you want, if the question will be asked like which one, what is the product of this reaction, so you will go for only major product. So in order to do the major product directly, instead of drawing the two products, what you need to do is follow Markovnikov's rule. And what does Markovnikov's rule says? The negative part will go to that carbon along double bond which has lesser number of hydrogen, and the positive part will go to that number of carbon which has greater number of hydrogen. Is that clear? Please let me know if you
Yes,
are,
sir.
if you got it. Please write it and let me know when you are done with it. Very good, Sneha. Sneha, do you have any doubt? Please retain this concept in your mind so that it will be very easy to do best in your exams. This is a very important reaction, and in organic chemistry, as you can see, the reaction repeats itself. Like here in hydration of alkene, in the presence of acid, you can see Markovnikov's follow. That we have already studied it in class 11th as well as class 12th, haloalkanes and haloarenes chapter. Hamza, are you done with this?
Sir, can you scroll down a little bit?
Scroll down or up? Are you saying this or this?
Down. Yes, sir, that's it.
Okay, thank you.
No, sir, down.
Is this okay?
Yes, sir.
Oh,
Yes, sir.
sorry. Please let me know everyone when you are done with this. So how do we know which product is minor or major? So, Alia, have you studied about Markovnikov's? Do you know what is Markovnikov? So what does Markovnikov says? Negative part of the addendum. Negative part of the addendum will go to that carbon along double bond which has lesser number of hydrogen. Which has lesser number of hydrogen. So that's why OH will go to this C, and this will be the major product. And you can also see This is 2-degree alcohol, this is 1-degree alcohol. 2-degree alcohol is more stable here. Okay. Please ask me again if you have any doubt, any one of you. Can I change the slide, Nafisa?
Yes, sir.
Okay, Hamza, what about you?
Yes, sir.
Okay. Now see, I'm going to give you a question which is very easy, and then we will see about its mechanism. So can I write, can I write, mm, okay. Can I write bond line structure formula if we have an alkene like this, and you are going to react it with H2O in the presence of H plus, then tell me the name of the product again if we have this H2 in the presence of H plus. Please let me know. Let me know if anyone have any doubt in.
Sir, uh,
Yes, can you
there
tell
will
me the
be
there will be?
there will be OH in the, like, in the double bond where there is double bond. So it's there.
Here are you talking about?
Yes.
Okay, can't you name the product? You can write the IUPAC name of the product, right?
Yes, sir.
Okay, so just name it and I'll get the answer. Simple.
Sir, propanol.
Do you know what does prop means?
3. Okay, butanol, sir.
Is it
4.
butanol or butane 2-ol? OH group on the first carbon, are you getting it?
Butane 2-ol, because it's in the
2-ol.
second.
See, first of all, you have to see whether it is, can you tell me whether it is symmetrical or asymmetrical? Any one of you? Hamza, Sneha, Alia, Nafisa, can you tell me whether it is uh, symmetrical or asymmetrical?
Asymmetrical, because
No, it's symmetrical, I think. If you're going to break the bond here, won't it be symmetrical? Isn't it symmetrical? It is like this
yes, sir.
part and like this part, they are almost symmetrical. And in order to find
Yes,
whether it is symmetrical or not, so just count the number of hydrogen on carbon across double bond. This will have one hydrogen, this will also have one hydrogen, so it is symmetrical. We can see that. So what you need to do, just bond breaking and H plus or H minus, and in symmetrical compound you can add wherever you want to add OH or H. H is hidden here, so the name will be basically butane 2-ol. Okay, And if you are going to see this,
Yes, sir.
what about this? Can you name the product of this? You have a lot of
Uh,
confusion in
butane triol.
ethane butane triol. Are you saying that the all three all that represents alcohol group on the third carbon, right?
Yes.
Whenever you are going to name or write the IUPAC of a compound, you have, and if there is any functional group present, we are going to give preference to that functional group. So in order to give preference to that functional group, what you need to do is do the numbering from where functional group gets the lowest position. So instead of doing numbering from left to right, you should do the numbering from right to left. Are you getting my point?
Yes, sir.
So what you need to do, H2 will be H plus OH minus, and this will be like this bond will be broken. And since it is asymmetrical, there will be two product, a possibility of two product. One will be major and one will be minor. Major product will be formed accordance with Markovnikov. And what does Markovnikov says? As you know that there will be one hydrogen and there will be two hydrogen. And what does Markovnikov says? Negative part of the addendum will go to that carbon along double bond which has lesser number of hydrogen, and positive part of the addendum will go to that carbon along double bond which has greater number of hydrogen. So the product will be like this, and you have to do numbering from here in order to give preference to this functional group. So its name will be butane 2 all. Is that
Yes.
clear, everyone? So please write it, Sneha, Hamza, Alia.
Sir.
Okay. Can I change the slide?
No, sir. Still
Yes, sir.
writing.
Okay, please do write it and let me know when you are done with this.
Yes, sir. Finish.
Thank you. The steps in this mechanism. How the reactions takes place, what is the intermediate and everything. So you can see the mechanism. The first step, I'm going to write it step by step. So step one is protonation of alcohol. Protonation of alkene. Sorry, protonation of alkene. Can anyone tell me what is this protonation? Nafisa, what is protonation? Nafisa, what is Can anyone tell me what is protonation? Nafisa, Hamza, Sneha, Alia. So see, basically protonation means addition of proton, and proton that means H plus. So in the first step, addition of hydrogen, not hydrogen, H plus. Hydrogen has electron and proton as well. and H plus is the only element which has only proton left. There is no neutron and electron in H plus. So basically in the mechanism, protonation of alkene will take place to form carbocation. And how does it take place? So first of all, we are going to add H plus, that means proton, or you can say acid, in water, and it will form H3O positive, which is called hydronium ion, which is called hydronium ion. And the next is the first step. See, this is your alkene. This is your alkene. And if you have H3O positive, that means this you can see. And can anyone tell me, positive charge on oxygen is less stable or more stable? Positive charge on oxygen, less stable or more stable? Nafisa, Sneha, Hamza. So always remember this point. Positive charge, basically when an on more electronegative element, as you know that oxygen is second most electronegative element. Second most electronegative element. On more electronegative element, positive charge less stable and negative charge more stable. Most electronegative or more electronegative element, negative charge more stable, positive charge less stable. So in order to stabilize itself, oxygen will take electron from this hydrogen, and what does it form? You can see this will form H2 and eliminate from here. Now you can see this is double bond, and since hydrogen is giving one of its electron to oxygen, now this hydrogen will have deficiency of electron. So this double bond will attack here, and this double bond will be broken. This double bond will be broken, and hydrogen will come to this, and this already has two bonds, and there will be formation of positive charge. How does this takes place? This is one bond, that means two electrons. So these two electrons, one of the electron will go to hydrogen, and it will have one electron, and this hydrogen and this electron will make a bond like this. And since this electron donated by this carbon, so it will have positive charge, and in this way carbocation formation takes place by the electrophilic attack of H3O positive. So this is step 1. Please write it. Then I will talk about step 2.
Yes, sir. Yes, sir. Finish.
Everyone done with this? Very good. Now we are going to talk about the next step, that is step 2. Step 2, you can see nucleophilic attack of water on carbocation. Nucleophilic attack of water on carbocation. So in the previous step, the product will be written as reactant here, and as you can see that this is carbocation, that means electron deficient element. So this will attack here because it will act as a nucleophile, and this will act as an electrophile. And what happens here, it's very easy to understand. So there will be two bond, and now you can see here it is this, and since it is donating one of its electron, oxygen, so it will have again like this. Is that clear? So this is how nucleophilic attack of water on carbocation takes place, and then the step 3 will take place. So first, let me write the step 3, then I will explain the both step. Deprotonation to form an alcohol. So see, when since it is nucleophile, it will attack carbocation to satisfy this carbocation, and you can also see that oxygen has positive charge now. So in order to stabilize itself, it will take one electron from hydrogen, and deprotonation will take place. Protonation, that means addition of H plus, and deprotonation, that means uh, removal of H plus. So see how it will take place. This was the bond, and then here it is. So what happens here? It's very easy. Since the reaction, this is present, this is in water, so this will take electron from here and it will attack here. So we will get alcohol here. We will get alcohol, and there will be removal of H2. Please write it. This is the mechanism.
Yes, sir. Finished.
Everyone done with this? Hamza Sekhani, Sneha. Okay. So this was the first method to prepare alcohol from alkene. So second method is basically, it is also from alkene, and this method is known as by hydroboration. By hydroboration oxidation. By hydroboration oxidation. So basically there is diborane, that is BH3 whole twice. That means basically B2H6 reacts with alkanes to give trialkyl boranes. Trialkyl boranes as addition. This is addition. Addition product. And this is oxidized to alcohol by hydrogen peroxide in the presence of aqueous sodium hydroxide. Please write it.
Yes, sir. Finish.
Everyone done with this? Sneha, Hamza, Alia.
Yes, sir.
Okay, take your time, Alia. So basically, there will be diborane. We are going to react an alkene with diborane. Then there, basically, that reaction will be in three steps, and we will get trialkyl boranes. We will get trialkyl boranes. And then if we are going to oxidize this trialkyl boranes in the presence of hydrogen peroxide, basically this hydrogen peroxide is oxidizing agent in the presence of aqueous sodium hydroxide, then we will get alcohol. Then we will get alcohol. Please write it. Very good. So see the reaction, it's very easy to understand. So if you have an alkene CH3 CH double bond CH2, and if you have this H BH2 fold twice, to see what happens here, it's very easy to understand. This bond will be broken, and this bond will be also broken, and this will be H plus and this will be OH minus, and this reaction proceed accordance with anti-Markovnikov. Anti-Markovnikov. Can anyone tell me what is anti-Markovnikov? Can anyone tell me what is anti-Markovnikov? Nafisa, Hamza.
Yes, sir.
What is anti-Markovnikov? Anyone is not responding. If you don't know, please let me know that you don't remember it. What is Markovnikov? Nafisa, are you there? Sneha,
Sir.
what is this anti-Markovnikov? It is opposite of
Uh,
Markovnikov. You can see negative part will go to that carbon which has greater number of hydrogen. What does Markovnikov says? Negative part, negative addendum will go to that carbon which has lesser number of hydrogen, and here negative part of negative addendum will go to that carbon which has greater number of hydrogen. Opposite. Are you getting my point, Nafisa and everyone?
yes, yes, sir.
Hamza.
Yes, sir.
Actually, I'm not writing the definition of this anti-Markovnikov because we have already done it in the previous class. Sorry, previous chapter, that is haloalkane and haloarenes. Markovnikov, that means negative part will go across double bond to that carbon which has lesser number of hydrogen, and anti-Markovnikov, negative part will go across double bond to that carbon which has greater number of hydrogen. So you can see that this bond will be broken CH3, and you can see CH it is. So positive H will go to this carbon, now it will be CH2, and again this will be CH2, and then this will be BH, because negative part, this negative part H plus, I wrote H plus, it's wrong. Basically this is H plus and this is BH2 minus. So this BH2 will go to this carbon. Is this clear to everyone? Is this clear to
Yes, sir.
everyone? Please let me know, because this reaction will proceed in three steps. Sneha and Alia, please do respond. Okay. Okay. Now see, again, the next step will be proceeded by CH3 CH double bond CH2. We are going to react this product with this reactant, and again there will be same procedure. I'm going to write this BH2 as, can I write this BH2 as BHH? Can I write this? Yes or no? Please tell me.
Yes, sir.
Now see, this bond will be broken, and this is positive and this is negative. This is positive part and this is negative part, and this bond will be broken. What is anti-Markovnikov? Negative part will go to that carbon which has greater number of hydrogen, and positive part will go to that carbon which has lesser number of hydrogen. So first of all, I am going to write this point. So please be focused. CH3, CH2, and then CH2. Now, so I'm going to write this BH, and BH will be directly connected with this CH2 and then CH. And you can see this after this CH2, there is CH which is connected with this H. So it will be H and then CH3. Can I write this? Please let me know.
Yes, sir.
Very good. Again, can I write like this? So if you are going to look at it carefully, CH3, CH2, CH2, and if you are going to look at this CH3, CH2, CH2, so it will be CH3, CH2, CH2 whole twice because both are same, and BH. Can I write this? Hamza Shekhani, Sneha.
Yes, sir, you can.
Now see, oh sorry, I'm going to take this as reactant because I already told you this will be proceeded in three different steps. So I'm going to take this as reactant CH3, CH2, CH2, and it's whole twice and then BH. Can I write this BH as this? And reacting with this again, same CH3, CH double bond CH2. So this bond will be broken, this bond will be broken. This is positive, this is negative. Negative will go to that carbon which has greater number of hydrogen, and positive will go to that carbon which has less number of hydrogen. So first I'm going to write this CH3, CH2, CH2 whole twice, and then this B will be directly connected with this CH2. You can see, and then this CH2, and then this CH2. And you can see this and this are same. So I'm going to write it CH3, CH2, CH2 whole thrice boron. So first of all, please write up to this, and then we are going to do the next step in this series. So please write from here and let me know when you are done with this.
Sir, can you scroll down?
Yes. Can you explain second step with CH3, CH2, CH2, BH first, but then how is it? I didn't write any double bond there. Alia, second step. So this is the first step you can see. So if you are first you are going to react this alkene with diborane and then whatever the product with the alkene, and again whatever the product you get again with the alkene. So if you are going to react this will be, you can see this is negative, this is positive. What does anti-Markovnikov say? Negative will go to that carbon which has greater number of hydrogen. So this will directly connect with this, and this CH will have this hydrogen. Okay, Alia. Scroll up. Let me know when you are done with this and whatever you need to do. Done, everyone? Nafisa, are you also done with this?
So can you scroll down for 1 second? Yes, sir, finish.
Now see, this is now we are going to prepare basically alcohol. So it's not alcohol. So what we need to do at the end is CH3, CH2, CH2. Whole thrice will be reacting with H2O in the presence of hydrogen peroxide, hydrogen peroxide, and aqueous medium sodium hydroxide. Then you will get 3 moles of alcohol along with BOH whole twice, which is bipolar. The reaction is very easy. If you have given in 1 marks question, you can directly write it in the way I will explain it. Please write the last step.
Yes, sir, finish.
Everyone done with this? Alia, okay. Now see, if the you can see the question is given like CH3 CH double bond CH2, and if you have given that it is reacting with BH3 whole thrice, the whole twice, and then H2O2, and then in the presence of OH and H2O. So what you need to do is very simple. Just make a 3 moles of this 1 degree alcohol. So in the previous class, reaction you can see Markovnikov follow, but here you can see H2O has two part, H plus and OH minus, and here anti-Markovnikovs follow, anti-Markovnikovs. So what I did is very simple to understand. Anti-Markovnikov, that means negative part of the addendum will go to that carbon which has greater number of hydrogen, and positive part of addendum will go to that carbon, and just make it 3 moles and you will get your answer directly. Got it? Nafisa, Hamza,
Yes, sir.
Alia, Sneha, please write it and write the product of this.
Sir, it will be CH3, CH2, CH, and then down there's H, and then OH.
Yes, it's good. Correct. So, Nafisa, why don't you answer it in terms of its IUPAC name instead of telling me CH3, CH2? CH3, CH3, sorry, CH3, CH2, CH2, and then you can see 3 moles of this.
Pro-
So it is basically
Propanol,
butane one, or why you always
butanol.
call prop?
I thought there was three, sir.
It's butane. Hmm. It's 4 carbon. So
Okay,
everyone
sir.
done with this? Alia, Alia, very good. You have done it correctly. Uh, Sneha, okay. I'm going to give you some questions regarding nomenclature or whatever we studied. It's a little test. Let me know when you are done with this writing this question. Then I'll give another questions. Nafisa, are you done with this?
Yes, sir.
Okay. So I'm going to give you another question. Write a structures of compounds whose IUPAC names are as follows. 1-ethoxypropane, cyclopent 3-in-1-ol, 4-chloro 3-ethyl butane 1-ol, 1-phenyl propane 2-ol, cyclohexyl methane. Please do this. Wait. Nafisa, are you done with the question? Have you written all the question? Everyone?
Yes, sir.
Okay, so after doing this, please send it to the PDF form and your homework also, everyone.
Yes, sir.
And I'm here for a while. If you need to scroll up, if please let me know. Everyone have written the question, right?
Yes, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.
Yes, Hamza, did you say anything? Alia, are you done with this? Hamza and Alia. Okay, you may leave the meeting and send the questions to me on my WhatsApp. Okay, thank you. Hamza Sekhani, what about you? Hamza Sekhani.